Let's say you have a Dell laptop in your hands. It's dirty. You plug that thing in, let's keep in mind that this is USB-C, and you hear fan spin, or if you have a power meter, you see something about 20 volts and 180 milliamps. Now that's bad. The 20 volts is indicating that the power delivery IC is working, because it's negotiating from 5 to 20. The most commonly found power delivery chip on phones and laptops is a TPS and then different models. The 180 milliamps while the device is off, that means something's eating power that shouldn't be. Somebody has been in here before and I can see something has exploded and the previous person has removed that chip from the board. That's probably a MOSFET, and next to it is another small MOSFET which is burned. Usually you could say that a burned MOSFET is all of the power straight into your CPU. But depending on what type of CPU and motherboard it is and how the manufacturer designed it, it might still be savable. Because I'm a little bit of a fancy pants, I have a thermal camera which will help a lot in identifying what's getting hot. Power is plugged in and it seems that the chipset is getting hot. Now the heat spot on it is uniform, which means that it's spread out evenly, which might indicate that it's not the fault. It depends on how hot the chipset is getting. So now we take off the heatsink to check what do we have. Is it a CPU? Is it a GPU? And someone's been here before. Now just before we look at those CPU GPUs, I just want to show you what the exploded part of the motherboard looks, where those two MOSFETs were. So power is plugged in again, and here's what the chipset looks like. Uniform big spreaded heat, and this is how the CPU looks like. Has a small pointy dot with a heat spot. Congratulations, it's cooked. Now thanks to Dell's engineers, they've put in some magical LEDs at the bottom of the device to indicate that the CPU is dead. That's of course if you look at the lights code that they've documented. Thanks Dell for making documentation how to identify a dead CPU instead of implementing some type of protection in the motherboard. Now what can we do going forward? We can repair all of the issues on the motherboard and swap a CPU, but that's only doable if you can find a healthy CPU and if you have the equipment to desolder such big BGA chips. I don't have a healthy CPU and Intel doesn't sell them, and I don't have a BGA machine. Option 2 is to swap a motherboard. In my case, I was not able to find any of these online. So in that case, it's just a donor motherboard for other patients to be revived. Just for science, I just wanted to check how good the damage was on the motherboard. If it wasn't the CPU, this part can be easily repaired. This catastrophe is also repairable. Looking at the back of the CPU, we can see that there was something getting a lot of heat in there. Now we're going to remove the CPU for two reasons. To check how bad does it look underneath, and so that I could mark this donor board CPU dead. The heart has been removed, and let's check what it looks like. The chip is very big, so I was not able to provide equal heat all over the board, so that's why you see some solder balls. But we were looking for some damage in the traces or a hole or a burn mark, which we cannot see here, which probably means that it's transistors inside that are burned. Glancing over at the bottom of the CPU, we can see the same story. Nothing severe except those solder balls and a sad ending to the story of a not repairable laptop. Thanks Intel. Thanks Dell. Thanks No Right to Repair movement in 2025. And thank you to the viewer for watching, and I wish you a lovely day.